bit better and making sure we don't step on each other's time. Um, for those of you that were in last month's session, you know that we kind of started off with discussing some of these things like the addressing situation for all the nodes, and this would be the spreadsheet. And again, anybody who wants that, by all means, send me an email. Be happy to send it to you. It is in a Dropbox folder, and I think most of the territory managers also have this, so they could probably forward it to you. So, just a reminder of where I'll be getting the addresses from. I thought this month we would start out, again, we talked about just bringing in a discrete signal from last time. This month we're going to start out with talking about a few things like thresholds and things that help you take that next step when it comes to doing the DXM100 software. Excuse me. So, I have attached to my system, I have a banner DX80 N9 X1S-P6 node, which is the temperature and vibration node, or the single wire serial node. So it will do temperature and vibration, temperature and humidity, and it'll also do the ultrasonic, the single wire serial ultrasonic sensor. So all the single wire serial products can be attached to this node. It is a battery node. And one of the things that we discussed last time as well was going into, let me get that opened up. I meant to do that already. I apologize. If we go into our software, into our DX80 user configuration tool, let me bring this in, and we connect to our system. So I'm going to go to my connection settings. I am attached over Ethernet, so I can connect now. And if mine happens to be node number 3. So if I tell it to get node, it's going to go out and it's going to search my network, and it's going to load up here, and it's going to tell me my devices that I've got. Now, this is a really important step when you're using a battery or a flex-powered node, because the report rate and the polling rate are very important to you. You want to make sure to get those at a time state long enough so that you're not just killing your battery. I know early on when we first brought this out, we had a few issues with having the battery polling too fast, and we were just killing the battery. So with the introduction of this software, we are now able to do it pretty easily, go into it, and actually load our time parameter so we can set that report rate and polling rate at a time that'll conserve our battery. So as this thing's kind of loading up here, we'll get on with it here in just a second. So again, I do have this set up with a temperature and vibration node. This is a serial read. Now, one thing I do want to kind of show you. So with that sensor, that would be the VT1 sensor, it tells me that my register for RMS Z-axis RMS velocity is register number 1. My temperature in Fahrenheit would be register number 3. And my x-axis RMS in inches per second is register number 5. Now that would be the 5th register in your node. And if you refer to our spreadsheet, node number 3, I'm going to be looking at register 49, 51, and 53. So this would be our z-axis, temperature F, and this would be our x-axis. So we'll go ahead and minimize this. So my input 1 is important to me, and it defaults to 5 minutes. So just to maximize that battery life, I'm going to set that to 15-minute sample rate and a 15-minute report rate. Now, again, sample rate is how often the node looks at the sensor. Report rate is how often the gateway looks at the node, or how often the node, I should say, reports its data. Now, we can drop on down here and we can do our input 3, which is our temperature F, and it tells us that. And I can make that 15 minutes. And that 15 minutes. And I can send that. And I can go back and send that one. And then my register number 5, I'm going to do that same thing. Let me scroll down here a little bit. And I'm going to make it 15 and 15. And I'm going to send it. So that tells my node, hey, this is the time factors that I want you to use. I'm going to make sure I sent this one. Yeah. So again, this is an important step when you're using a flex-powered or a battery-operated node. This gives you the ability to set your time factor so it saves or maximizes your battery life. With our lithium-ion 3.6 volt wet cell D-cell battery, if you set that to 15 minutes, that maximizes the battery life. The expected battery life is 5 years. So if we set it for 15 minutes, that maximizes our 5-year setting. Now, it's not to say that the battery won't last long, that longer than that 5-year or shorter, but the expected battery life is 5 years at a 15-minute sample rate. It's been my experience with temperature and vibration, which has been a very good seller in our area. We've done a great job with that product. The territory managers and the distributors in my area have done a really good job bringing that out. We've had good success with it. What I found is that most customers are checking their motors, their vibration and temperature, at best every 30 days, sometimes 60 or 90 days. So we're taking them from a place where they were doing monthly, bi-monthly, 3 months, twice a year, to every 15 minutes. So that's a pretty good step forward. So again, we'd want to use the DX80 user configuration tool version 2. I am connected through a DXM100 gateway, and I'm talking to my node, and I'm setting these parameters. So I'm going to go ahead and close this software because I'm kind of finished with it. And now I need, again, remember our DXM software, we need to name a couple registers. So I'm just going to move mine into register 1, and I can make the choice here whether I want to display it on my LCD screen. I can make the choice if I want to scale it here or what I want to do with it. But I could simply say that this is, let's just call it Vibe 1 for sake of short conversation. And remember that if I want to log this data, this unit, this DXM, has an 8 gigabyte SD card built in it. This is where I tell it, I want you to go to log 1. So I'm going to just real quickly, I'm going to do temp. And I want to read this out to my screen, and I want to log it. And I'll do the same thing with my other vibration. Whoops. Up 2. And I'll read this to my screen, and I will log this as well. Now, so that's just my 3 parameters. This is my local registers. Everything that happens in a DXM must happen in the local registers. Now I want to map this, and I want to add a read rule. And one of the things that I want to do is I'm going to read basically all the parameters. Well, I can't do that because I set it up for just 3. So I'm going to read 1 register, and we're going to refer back to our Excel sheet. I want to get register 49, 51, and 53. So I'm going to tell it I want to start registers at 49, and I want to move it into local register 1. And then I want to read one register starting at 51 and move that into register 2. And again, I'm going to add a read rule, and it'll be 53, and I'm going to move that into register 3. So now I've told my system, hey, I want you to go grab these 3 registers, these 3 parameters, and I want you to bring them into my gateway so I can do something with them. Now, we did this last time, but to go through the exercise again, all I did was set up a read rule that moves my data into a local register. Well, a lot of people want to set up some type of an alarm. They want to do something with that data other than just log it. So the DXM allows us to use what's called an action rule. So I could set up a simple threshold rule. And I can just say when local register 1, which is my vibe, I could say equal to or less than, equal to or greater than, or I'm sorry, greater than, equal to, less than, equal to, or equal to. So I'm going to grab a greater than or equal to some value. Now, I'm going to use the term baseline. So generally what you would want to do is have this sensor running on your motor so you know about where its base vibration is. So everything you know about where it should be running when everything's good, and you could put a number here. Now I'm just going to put in 1500, which would be a very low number. So just so you know, this would be the same as 0.15 inches per second vibration, which would be a pretty low vibration. This would be motor would be running pretty well. Now, I can say when this is true, I want to do something with it. So this is where I would start using some of my other local registers. And one of the things that I like to do, and again, this is up to the programmer, is I like to move these out of my way. So I want to say when this is true, I want to set local register, let's just say 100, to a value of 1, which just means I'm turning it on. So when this is true, when this happens, local register 1 is going to have a 1 in it. And then when it's not true, I'm going to move it back to a 0. You also have the ability here to say, hey, wait a minute. Now, if this just spikes, I don't really care. Maybe something happened. Maybe somebody hung something or whatever. So I can say that this has to be on for a minimum of 5 minutes. I don't know, just to come up with a number. And then if it does happen, I want it to stay on for a little while because I want to know that something happened. So it actually has to go low for, let's say, 10 minutes. I don't know, just again, whatever number. It tells me that once it goes back below that, I'm going to leave this value of 1 for 10 minutes. So it has to happen for 5 minutes, and then at a minimum, it's going to be on for 10. Now, I will bring up, although we should probably do this in a separate session, this allows me the ability to send an email or a text message based on this event. But again, next meeting, probably next month, we'll get a little deeper into that. So I've created this threshold rule, and it says that I'm going to do something. I'm going to turn this register 100 on. Well, now maybe I want to do something with that. So if I take this mapping, and I go to a write rule, then I can say that I want to, when that happens, I want to turn on a light. Now, the DXM100 and 150 have 4 built-in LEDs. And again, I've told you guys in the last session, you have to think of this DXM100 as actually multiple things. So you have a gateway, which is one thing. You have the controller section, or the PLC, if you will. That's another thing. You have a board in the back that has your built-in I/O, and that's another thing. And then you have the LCD, which is actually another thing. Now, if I want to do something with those little LEDs on the front of my DXM, and I want to turn one on in the case of an event, I can say I want to write register 100. Now, if I want to use that LCD board, it is actually slave ID 201. Now, if you remember from our read rules, everything in our wireless when we're using performance radios will always be slave ID 1. In the case of my LCD board, it's slave ID 201. The first register for that first LED at the top is actually 1102. And this can be found in the data sheet for the DXM if you want to check up on me. But it's slave ID 201 for the LCD screen, register 1102. So now when my vibration goes high, now I can do something with that. I can bring on a screen. By the same token, if I wanted to turn on one of my discrete outputs, so I could say local register 100. And again, the slave ID for my I/O board is actually 200. And I can say that I want to write that out to an output. So on my slave ID 200, my first output's address would be 501. So 501, 2, 3, 4, or in the case of a DXM150, then you'd go on out to 508. So this would be how I could use my DXM to turn on a light. Now, we know that generally speaking, we're going to probably use a TL70 tower light, a wireless TL70 to turn on a light. That would just be right into the output of the register on that. But the functionality here is the same. So, I've quickly created an action rule that allows me to have an out that turns on a register that tells me that an event happened. I map that out to my DXM base. Here my LED, my LCD, the face of it, and here is actually the I/O board, the inputs and outputs that's built into my DXM. So either way, I can get an output from that event. So notice a few minutes ago that I mentioned the log file. So if I go into my settings and I go into logging, I want to create a data log. And if I create that data log, I've got the option, I want to enable my data log 1. Now, here is a big step forward in the DXM100. When we first started with this unit, we only had the option of UCT time, which is a universal time, kind of similar to Greenwich Mean Time. But in the new version, version 3, we can actually use local time for our log, and this makes it a good bit easier. This is a good thing. Now I can set my rate. How fast do I want to log this data? Maybe I only want to log it every 30 minutes. I don't know, maybe once an hour. It's whatever works for your system. Now, that's pretty much, if all I want to do is generally log, that's all I have to do to this log file. So now when I load it, it would actually start creating a log file. And I'm going to connect to this, my unit here. Connect. And I don't remember if I have a log file running in my one. Yep, I sure do. So this is what it would look like. So if I want to get data out of my DXM, I would simply refresh the list, and then I would bring in my log file. So now I could do something with that. I could save it. I can import it into an Excel spreadsheet. But from here, I have the ability to do something with this log. Again, a big step with the DXM100 is the Ethernet connectivity, so your customers can have that DXM at a remote location. They can also go in over Ethernet, pull this log file, and actually see the data. And a lot of times, for me, I've used this a great deal for temperature and vibration and temperature and humidity. That have been the two things that I've mostly set up data log files for. Now, if it's just sitting out there running and you don't want to create a bunch of data, meaningless data, you've got the ability to only log when a register, some register, is above a value. So I could say when register number 1 is greater than 0, or when my event happens, which was register 100. Now, when my event happens based on my threshold event, now I can start logging. So now it would only log when it goes into an alarm state. This would probably be, this would be a preferable way of setting this guy up. And again, this is kind of new with the version 3 software. So this is a pretty good thing. I've got, good many people kind of looking at that. So again, we've set up a data log. We've learned to go get that from our unit. And then we've got this log file that's here. And I have no idea what's in this log file. But I can save this now, save it into my computer, and then I've probably already got one, so it's going to tell me it wants to save over it. And I can say yes. And once that's saved to my computer, now I have that. So again, let me go over and bring that guy up. And then I'll pull it back in just to kind of show you what it's going to look like. Yeah. So I'm going to bring this back over. And it's in text format. So this is telling me that apparently mine's been running for a while. So since the 19th of October, I've got these values, these temperature values, back into my DXM. And we can look down through it, and I can see that, as winter kind of came on, I've obviously got it logging too fast, but as time moved on, we can watch those temperatures go down, and this gives your customer a way of using this. This is pretty easy to import into Excel if we needed to use an Excel file. So, again, local registers, just like we've done before, simply just name some registers. I map that data from my node over into my DXM. I had to read them into the DXM. I created an action rule that said when I have a value that goes above, and I want to set a threshold or a value, then I turn on a register. So that gives me a 1 or an on, so to speak. I set up a time, a hysteresis time here. Excuse me. And then once I set up that register 100, then I went back to mapping, and I mapped that out to an output. So I get some type of a warning that I had an event. Now, really quickly, I'm also going to mention the scheduler. This is another pretty cool feature that's built in to this system. So I could add a scheduled weekly event. So where would this happen? Maybe if I wanted to turn on a pump, or I wanted to use it for something. So I could say 5 days a week, Monday through Friday, I want to turn on something at a specific time. So it is in 24-hour format. So I could say at noon, I want to make something happen. And then I want it to stay on for a specific time. And maybe I only want it to stay on until, I don't know, 12:15. I don't know, guys. I'm making up numbers. But so now I've kind of created this, and I can say, again, my local register, I can say in my register 200. Maybe I want to get that totally out of my way. Every day at 12 o'clock, from 12 to 12:15, I'm turning on register 200. And now I can do something with that. Again, maybe I want to map that out to some node. Maybe I want to add a write rule, and I'm going to say when register 200, I want to take that out to one of my wireless nodes, and maybe it is node number 5, output 1 would be register 89. So slave ID 1, register 89. So now when that event happens, I turn on an output that does something. Turns on a pump, turns on a light, turns on a buzzer. It makes some event happen. And again, that's our scheduler. So I have the ability here to select the days that I want it to happen. Maybe I only want it to happen every Tuesday and Thursday and not on Mondays and Wednesdays. I don't know. It's totally up to the customer. It's a pretty cool little feature that we have here. We are using that occasionally as an email file, and again, we'll talk about that again probably next month. We'll discuss how we set up an email. So at this point, I've kind of rolled through a lot of stuff. Does anybody, if you have any questions, and I have not been monitoring the chat line, but if anybody has questions that they'd like for me to cover, go ahead and do so now, and we'll or if it's something that you just want to ask me on the side, feel free to send me an email, and we can do that as well. And I'll open up my email on my desktop here and just see if we have any questions. If you don't have questions or you're not interested any further, by all means, this is pretty much all I'm going to cover for this month. And I do thank you guys for coming in. This one was recorded, so it will be on the website just as soon as I can get it saved and put up on the website. And again, I'll just kind of see if anybody, so far I don't have any questions. So I either covered it really well or I put you guys to sleep, and I don't know which happened. So, all right. I didn't see any questions, so I thank you guys for your time today, and we'll continue to move forward with this demystifying the DXM100. I will be doing this same exact meeting again on Friday. If you want to send a customer to it, that'd be fine. So, again, thank you guys.
Thanks, Bob.
Thanks, Bob.